before we are going to our main topic, main presentation today, we have an engineer, Rahul Sajeet, who is working in Qatar China engineering company, who is doing the Al solar power project to give an overview of the current biggest solar project in Qatar. Engineer Rahul.
Hello, am I audible?
Yeah,
yes.
Yeah.
Yes, thank you. Thank you, everyone. Good evening to everyone. Yes, I hope my screen is visible to everyone. Yes, thank you. The solar panels and wind turbines are popping up in many places. So it is easy to assume that the transition from fossil fuels to renewable energy is well on its way. But in reality, it has barely begun. Scaling up solar energy to the level of oil and gas, it's a huge, huge task, but a huge, huge opportunity as well. The sun gives off more energy than we will ever need. But our limitation is harnessing that power in a cost-efficient way. Can sun ever be like oil and gas? Good evening, ladies and gentlemen. My name is Rahul Sajeet George, and I'm working in Power China, the main contractor of the 800 megawatt Al Kharsa solar PV independent power project. Today, I'm here to give you an overview of the first of the kind project in Qatar. Before we go ahead, let's look at some statistics. The price of a PV module has fallen by 99% over the last 4 decades. In 2009, the cost to generate 1 megawatt using a solar PV module costed $359, whereas in 2019, 10 years later, that price is $40. That itself is a price drop of $319 right there. That has paved the way for the project. So what can we expect in today's presentation? Well, first, a brief about the project. Why this project was initiated? Who are the stakeholders? What are their roles in the project? What is going to be the project output? What are the key components involved in this project? An illustration of the process flow, and lastly, the challenges. Well, firstly, let's look at some of the project highlights. This is a 800.15 megawatt power plant. This is the largest PV project using bifacial modules. And this is the first large-scale solar power plant in Qatar. It is located in Al Kharsa on a 10-kilometer square land. And Al Kharsa is 80 kilometers towards the west of Doha. Why was this project initiated? Well, firstly, it helps Qatar take a huge leap forward to its vision for 2030, and also helps in keeping its promise to host a carbon neutral FIFA World Cup next year. During its lifetime, the plant will reduce 26 million tons of carbon dioxide emission, which helps Qatar keeping its promise of reducing 1 million tons per year. And lastly, it contributes to the goal of sustainable development and reduce the reliance on gas power generation. What is the project output? Well, the first phase of the project is going to achieve grid connection of 400 megawatts. And upon completing the whole 800 megawatts, it will be able to meet 10% of the peak electricity demand in the country. Now, some of the technologies used in this project are the tracker system, bifacial panels, the latest automated system to track the sun, and robots for cleaning the solar panels. All these systems will be explained as we proceed. But before we go with that, let's look at the stakeholders in the project. Firstly, the client and the owner. The owner is Siraj One, a company formed by Siraj Energy and a developer consortium of Marubeni and Total Solar plants. 60% of the project is owned by Siraj Energy, which itself is a company consisting of two companies, Qatar General Electrical and Water Company and Qatar Petroleum. And the client is Karama, who has agreed the first 25 years they will buy electricity from Siraj One. And after these 25 years, the plant will be theirs. The main contractor for this project is Power China. That is the company I'm working for. Now, there are subcontractors involved in this project as well. For the PV department, under civil, we have Miko, Hydro, and Bark, who takes care of the piling and trenches. In the installation of the tracker system, we have Royal China, Jiangsu, Swift, and White Tower. And the electrical subcontractor is QEMC. The substation, the civil and MEP subcontractor is KG Group, and the electrical subcontractor is KBB. And lastly, the suppliers. Firstly, Idematic. They are the ones who have developed this technology and are supplying the tracker system. KBB is supplying the MV inverters. LS is supplying the fiber optic cable. Longi Solar is supplying us the PV modules. And SunGrow is giving us the inverters. Prism Group and Doha Cables provide us various cables that are needed for this project. Now coming to the key components of this project. Firstly, the foundation, the tracker, the bifacial panels, control of the panels, the power collection, and substation. Firstly, let's look at the foundation. For this project, we are using a pile foundation for each pedestal. When starting off with the project, it was decided that we would do direct ramming instead of piling. But upon geological investigation, it was found out that the surface beneath is rocky. It is really hard. And I found out it was difficult to do direct ramming, which was difficult to pedestal 1.5 meters deep, which was the required depth. And also it posed a risk of bending the sigma profile. Secondly, piling was a more cost-efficient way and time-saving as well. There are a total of 120,240 piles in this entire project. Now coming to the tracker structure, which is one of the most important components in this project. As you can see, this is an image of a tracker structure, how it looks like. On top over here is where PV modules will be mounted. More explanation of the tracker system will be coming ahead. There are a total of 5,009 trackers in the entire project. A tracker is, and the average length of a tracker is 180 meters, the height of 2.35 meters, and a width of approximately 4 meters. Now, this is how a traditional PV module looks like. It has an aluminum frame followed by tempered glass, 2 layers of a EVA encapsulant, between which the solar cells are placed, a backsheet, and a junction box. But for this project, we will not be using a traditional PV module. We will be using bifacial solar modules instead. The plant will consist approximately of 2 million bifacial solar panels. Now, bifacial solar panels are a smarter choice because they are able to absorb 11 to 20% more energy compared to a traditional PV module. To give you an idea, this is how the PV modules will be mounted. The light that is reflected off the ground will be captured from the backside as well. And this will give us more energy. And considering Qatar has an average throughout the year 9.5 hours of daylight, it is a really smart choice to go with. Now, coming to the tracker structure, which I'm sure most people will have questions regarding on, this is how a tracker structure will look like when it is completely mounted. But instead of the gears that are shown over here, we will be using a rope pulley system, considering the reality of Qatar. Now, what does the tracker structure exactly do? Let's say the sun rises from the east, and throughout the day it proceeds till it sets in the west. Now, when the sun rises, the tracker will be facing like this. And as it proceeds, as the sun moves throughout the day, the tracker follows the sun as well. This helps in absorbing the maximum amount of energy that it can. Now, coming to the maintenance, since the plant is located in a desert, there is a lot of maintenance that is required for the PV modules especially. We will be using robots to clean it. And the reason why we are able to use robots for cleaning is because of the 180-meter length that the tracker has. An important fact to remember is a tracker has 24 piles. Now, this is one of the most important part of the presentation, the illustration of the process flow. Now, throughout the plant, since it is 10 kilometers square of land, it is divided into various blocks, a total of 108 blocks to be total. Each block has roughly 46 trackers. Now, each tracker is, or rather the PV modules in the tracker are connected to an inverter. There are 30 inverters in each block. These 30 inverters are in turn connected to an MV station. There is one MV station in each block, which results in 108 MV stations throughout the plant, followed by which the MV stations are connected to the main control building. The main control building has two transformers, one which steps up the voltage to 132 kV and the second to 222 kV. This is connected to the main utility grid, which gives power to the entire country. Now, coming towards the end, what are the challenges we are facing in this project? Since it's the first kind of project in Qatar, there are a lot of challenges that are there. But the top two challenges that are there right now are the first one, manpower. We have roughly around 3,000 people working on this project, and we would need about 3,000 more for a smooth functioning. And secondly, one of the biggest challenges, and I'm sure this is an obvious one, is because it's the first kind of project in Qatar, getting experienced people is quite a big challenge. And most people in this project are learning on the job. And there are a lot of trainings that are given which causes slight delay in the work. But nevertheless, everyone working in this project is fully committed to achieving this so that the sun rises on a solar energy future. Thank you.
Thank you, Engineer Rahul, for giving that wonderful presentation overview of our Ultrasa 800 megawatt project. Thank you very much, sir.